Hello everyone, welcome to my YouTube channel Data Partnership. So today I'm talking about evapotranspiration. So in my previous videos I have shown how to load, how to use satellite product modis data for to understand evapotranspiration, high evapotranspiration and low evapotranspiration, and then in the Google Earth engine how to visualize that. Then we talked about evapotranspiration anomaly and how what are the situation in wet and dry air, so how to interpret those outputs, right? And now and also I created one video on evapotranspiration trends. What are the trends and what are the annual evapotranspiration. So in my last video, so please go through that also so that you can understand better. I am not the climate expert, but since it's data, because we are talking my channel is mainly talking about the data, so I am just trying to show you how to use those data set. And now you can improve your skills based on whatever I am telling here. So today I'm talking about evapotranspiration based drought index, right? Evapotranspiration is one of the indicator of drought. So how, so that we can say that whether this area is a drought prone area or it's not, right? Or wet area, whatever. So this is one of the indicator. It is not telling everything, but there are many other parameters also. So, so how much current evapotranspiration deviate from normal condition? This is the thing, right? So high ET means enough water, healthy vegetation. Low ET means water stress and drought. Because evapotranspiration will happen wherever is vegetation is there. If, well, this is a general thing. If it is not there, then it means drought. So this is the formula. ET transpiration anomaly is that ET current minus ET long term means, right? So thing is that each vegetation using more or less water than normal. Negative anomaly means vegetation stress, drought. Positive anomaly means healthy wet conditions. So why we are talking about this? Because it's simple, physically meaningful work. It is work. It works in urban and agriculture area, so easy to explain visually. And this is the data set we are using everywhere, right? So how to do that? This is simple thing. We have study area, we are loading the modis data, and then we are defining this data set from 2015 to 2022. We are just here declaring variable 80. So this is the thing, and we are clipping with our EOI, and then we are selecting the drought year 2023, right? So that we can understand. Then though simply I have already done that. These are the codes. So you can see here, so we have, this is our study area. You can withdraw from here. This is I have taken from here. You can change. If you take this thing, then it will come automatically here. You can change the name, anything, geometry, UI, study area, whatever. Then we have to show how, because uh, if you not show this, then this it will come somewhere else. So otherwise, so that's why EOI, or it will show this one if you run the code. Then we have selected this modis data. Then we have defined ET, baseline ET, right, is the 2015 to 2022. Then we have selected this drought ET. From field we have filtered 2023 1st January and to December 31st 2023. You can change 24, 25, whatever. So we are taking mean, multiply 0.1 and clip AOI. It's a simple thing which I am doing earlier also, right? So now we have to calculate ET anomaly. This is a variable again, drought ET dot subtract baseline ET minus the dot rename. We are just we have to drought ET. We are just subtracting this one from this from the earlier baseline one, right? Then we have just visualizing the, if you run there, then you will get the output, right? So it is happening here, right? So you can see here we have this image. Yeah. So you can see most of the area is white. White means, you can see that from here to 0, 1, 2, 3, 4 means from we are going lower to higher. Means now you can see here, if it is white means we have normal conditions, right? If we have dark red means very low evapotranspiration, means there is a severe drought possibility. If it is orange, then moderate drought. White means it is normal conditions. Light blue means wet condition. Blue means very wet. So this is the interpretation of this data set, right? The whatever we have done for my study area. So you can see we, because you should also refer my earlier video on urban versus urban where we have included urban area also. Otherwise, what happen is it masks the evapotranspiration for urban area is different. It is not for urban area. It is for every other areas also. Maybe you can try for that how to. What are the situation for dry conditions for urban areas, but it is not relevant for that, I think, right? So you can see we have this kind of we have white condition, otherwise we have mask. These are the masked one, right? So if you click here, you can check. If you click, then you will you can get the 1.6 AT anomalies, 1.6, right? So so that's it, right? So that is very useful parameter, I would say, for your if you are working in a water risk, you are trying to do water risk assessment, you want to understand the basing situations, right? So it is our drought area. So it is, or if you are trying to pull want to do any interventions in your watershed, so this is one of the parameter where you can work, right? So you can understand that. And also some in some point of time I will also try to relate evapotranspiration with the rainfall also. It means what is the relationship between these two in a particular area, right? So thank you. So please subscribe my channel, whatever I'm trying here to give you more and more content, so that it can be helpful, I'm sure about it. And you can improve it, right? I am also learning those codes and everything from here and there, right? So whatever I'm learning, I'm just trying putting here so that you can get the benefit out of it. Thank you very much.